I'm Ethan Kwan, and today I'm going to be showing you another proof of the Pythagorean Theorem. So the Pythagorean Theorem is basically where you have a right triangle. So let's draw a right triangle right now. Okay, so here's one side, here's the other, and here is the hypotenuse. Oops, the hypotenuse. Nope. The hypotenuse. There we go. Okay. So basically what the Pythagorean theorem says is if this is A and this is B and this is C, A squared plus B squared equals C squared. And I made a proof on this a few videos ago, or 2 videos ago, I guess. So today I'm going to be showing you another proof of the Pythagorean theorem. Okay. So, so what I'm gonna do is so first step into doing this is to take this whole thing and copy it, and then paste it, so it's exactly the same triangle, and turn it 90 degrees like this, and then put it onto here, like that. Oops, no, a little bit lower. There we go. Okay, so now we have this. We have, so here's C, here's B, here's A. Okay, so here we have a right triangle, 2 right triangles that are exactly the same. They're congruent. And here are our right angles. That's what makes it a right triangle, of course. Okay, so, let's see. So what we're going to do is we are going to first figure out this angle here. What is this angle? Oops, I might have given it away. Well, it looks like something, but let's try and prove that it is actually 90 degrees, because we think it's 90 degrees, right? We think this is a 90 degree triangle, and we know that it's right, but I'm going to prove to you that it's a 90 degree. Okay. So let's say this angle right here, the inner one, is theta. And theta is just a made-up, arbitrary Greek letter that we use to denote an angle that we don't know. So if this is theta and this is 90, this has to be 90 minus theta. Okay? And of course this is theta too, because they're exactly the same triangle. Okay, there we go. Okay, so now let's prove that this is all we need. Let's prove that this is a right triangle. Well, we know that B and A make a straight line, like this, right? This is a straight line. I didn't draw it straight, but it is a straight line, so that's 180 degrees. So that means that theta plus 90 minus theta plus our mystery angle equals 180 degrees, right? Okay, so the thetas cancel out. There's a theta here, there's a negative theta here. So we have 90 plus question mark equals 180 degrees. Okay, so now we have our equation here. Can we solve? Well, yeah, we can subtract 90 from both sides. And we're left with, well, the 90's cancel out here, so you have question mark equals, change colors again. So question mark equals 90 degrees. So yes, this is a right angle. Okay? Okay, so now what we're going to do is we're going to take our line tool, and we are going to draw a line from here to here. Okay? So now this forms a C by C triangle, and the area is 1/2 C squared. And this is going to be helpful. So what we want to calculate is the area of this entire figure. First we're going to try calculating the area based on the area of a trapezoid, and then after that, we're going to try and calculate the area based on all its component parts. Okay, so what's the area of a trapezoid? Well, it's the height, this length, times 1/2, well, 1/2 the average of the two top and bottom. So we have a plus b, because that's the height, right? The height is a plus b, times 1 divided by 2 times a plus b, because that's the average of those two lengths there, okay? Okay, so now we have this equation. So that's one of the sides. That's the area of the trapezoid. And now let's figure out by the area of its component parts. So a plus b, I'm just writing the equation up there. A plus b times 1/2 a plus b. Okay, so, and that is equal to, and because all the component parts are equal to the area of a trapezoid, so they're going to be equal to. Okay, so what's the area of a triangle? Because all these are made up of triangles, right? Okay, and the two areas are going to be equal because they're the same figure. Okay, so what is the area of this figure here? Or a better question is, what is the area of this figure here? Well, the area of that figure there is going to be the height times, the height here times the width, divided by 2. So it's going to be a times b divided by 2, or 1/2 a times b. But there are two of them. So what we're going to do is we are going to, nope, not that one. Let's see. Okay, so if it's a times, let's just scroll down a little. Okay, so let's scroll down more. Okay, so the area of a triangle is 1/2 base times height. But there are two identical triangles, here and here. So that's just going to be a times b, because both of them are 1/2 a times b. If we multiply that by 2, because there are two of them, we get a times b. So we have a times b twice, or 1/2 twice, so that's just 1, plus the area of the big triangle, this triangle here, or c, 1/2 c. Okay, actually it's going to be c squared because there are two of them. Okay, so I don't really like these 1/2s hanging around, so first of all, let's simplify this left-hand side. How can we do that? Well, we can combine like terms. We can do 1/2 a plus b squared, right? Because there are two of them, is equal to a plus b plus, a plus b times a plus b plus 1/2 c squared. And I don't really like these 1/2, so let's multiply the whole thing by 2. So 2, multiply this by 2. So the 2's cancel out here, and the 2's cancel out here and here. So you get, no, wait a second. No, this is going to be times. Sorry. A times b, this is going to be a times b. Okay. Because, yeah, let's see. A times b. Well, not this one. No, this is going to be plus. Okay. That looks funny. Okay. So we have, the final equation is a plus b squared is equal to, let's see. So, if that's a times b, then we can just write it as ab plus c squared. And actually it's going to be 2ab because we multiplied this whole thing like that, so distributive property, so it's going to be 2ab plus c squared. So what's ab squared? Well, just randomly change colors for no reason again. Okay, so, okay, so let's, Okay, so now let's simplify this. What's a plus b squared? Well, that's going to be a squared plus 2ab plus b squared, right? And if you don't know what I'm doing here, well, you should check out my a video on factoring, okay? Or FOIL. Okay, and that is equal to 2ab plus c squared, okay? So that, let me just color this differently. Okay, so now what we're going to do is we are going to subtract 2ab from both sides, and I think we deserve a little bit of a drum roll here. 2ab cancels out with 2ab, 2ab cancels out with 2ab, and you're left with, drum roll please, a squared plus b squared equals c squared. Okay, so we did it, guys. We proved the Pythagorean Theorem. Okay, I hope you enjoyed this video. If you like this video, please subscribe, share this channel with others, and hit that bell button. Also, put a like on this video if you liked it. If you disliked it, hit the thumbs down button. I'm assuming that's what it's for. If you liked it, please hit the thumbs up button, subscribe, and share this channel with others. Also hit that bell button, the bell thingy on my channel, so you never miss an upcoming video. Otherwise, thank you for watching. See you at howtodostufffwithhim.com, and see you next time. Bye. Bye. I said bye. Bye.